Assalamualaikum to my dearest panel, Associate Prof. Dr. Muhammad Nawawi Suraji and Dr. Khairul Safwan Muhammad. My name is Azmi Aizah Hakimi Azaman, a final year student under the supervision of Associate Prof. IR Dr. Ahmad Farid Abidin. Today, I will present my final year project, which is analysis of unbalanced fault location under dynamic load. Let's get down to the introduction. In these days, transmission and distribution system become the most important thing because when power or electric is generated, this system will distribute the power to the load. Without a good and reliable system, power and electric cannot be supplied to the loads. Unfortunately, problems can occur in the system which are due to the faults. Faults in distribution system can be categorized into two, which are balanced and unbalanced fault. When this fault happens, it will affect the power distribution system and can lead to various unwanted problems. Thus, fault location is needed to prevent the fault from happening. To prevent the fault from becoming worse and damaging the transmission and distribution system, many papers have proposed methods to locate the fault and for passive and active load. There are also a few studies about dynamic load fault location for the past 5 years. However, there is dispute in the existing studies considering the dynamic load. Those studies may include the dynamic loads in the paper, but it does not analyze and compare the balanced and unbalanced fault in the system. Hence, the objectives of this project are to investigate and analyze the characteristic of fault voltage and the phase angle jump considering the dynamic load during balanced and unbalanced fault. This project also compares the three-phase balanced fault and single line to ground fault considering the dynamic load. There are four methodologies to perform this project, which are fault in the distribution system, phase angle jump, root mean square, and developed distribution system. First of all, faults can be categorized into two, which are balanced and unbalanced fault. For balanced fault, this project analyzes the three-phase balanced fault and single line to ground fault for the unbalanced fault. The faults can be calculated using the formula from 1 to 7. The admittance matrix in 8 can be used for single line to ground fault, and the admittance matrix in 9 can be used for the three-phase fault. Next is phase angle jump. Faults in the power system and the energization of torque induction motors can cause voltage set. Phase angle jump is when three-phase system shifts the zero crossing. The phase shifts is caused by the difference in the XR ratio between the source and the transmission or distribution system. Phase angle jump also can be triggered by the faults occurred in the system. The voltage set calculation in 1 and 2 can be used for balanced and unbalanced fault. The equation in 3 can be used to calculate the phase angle jump. After that, root mean square. Calculating the RMS voltage is better than calculate its magnitude and phase because the calculation is better and simpler and less complex. RMS also easier to analyze and is commonly used in power system analysis. This is because voltage magnitude calculation include the peak voltage for every cycle or half cycle in the equations, while RMS includes the power related calculation. The RMS can be calculated using the formula from 1 to 6. And for the fourth methodology, developed distribution system. This project developed a distribution system considering the dynamic load. The system is supplied by an 11 kV source with 50 Hz. The source is connected to a delta Y transformer with 400 volt as the output. Short transmission line is used for this system that supply a RL load with 6.5 kW and 3k ohm inductive power for a system without the dynamic load. For a system including the dynamic load, It supplied a RL load with 3.3 kilowatt and 6.5 kilo ohm inductive power, and a dynamic load with with 3 kilowatt and 1.5 kilo ohm inductive power. This is the process of this project. First, two simulation systems are developed. Then, both simulation systems will then be compared during two situations, which are with and without fault occurred to the system. The faults for the systems are located before and after the transformer. Faults for the faults, it categorized into two faults, which are single line to ground and three phase to ground fault. The results gained from each system and situation is observed and recorded. Lastly, the data obtained then be analyzed when doing the comparison. Now, I will present the results obtained from the simulation systems. The results are focused on the load bus for each system. For system without faults, both systems have almost the same values for voltage, current, and phase angle. In this situation, both systems can supply their loads without any interruption. After analyzing and comparing the results obtained on the load bus, the voltage for both of the systems is approximately 220 volt and has a current of 9.9 ampere. The phase angle jumps for RL load is 24.8 degree and the dynamic load has 26.2 degree phase angle jump. When single line to ground fault occurs, there is a big difference between before and after occurred fault. On the load bus, during the first fault, the RL load has 108.7 volt and 4.9 ampere, which are lower than the dynamic load voltage and current. But for the phase angle jump, the dynamic load has a lower phase angle and than the RL load with 7.8 degree. However, during the second fault, the dynamic load has lower voltage and current than the RL load. The dynamic load has 112.3 volt, 6 ampere, and 2.3 phase angle jump. When three-phase fault occurs on the load bus, both systems have the same voltage, which is 1.1 volt at the first fault location and 0.9 volt at the second fault location. Moreover, the phase angles for both systems during this type of fault are the same, which are 12.3 degree at the first location and 20.2 degree at the lowest angle at the second fault location. That's all for the results, and after finishing viewing the results, it's time for the conclusion. This paper considers the dynamic load in a distribution system and analyzes the effects of balanced and unbalanced fault to the RMS voltage and phase angle jumps on the system. The result obtained show that the voltage and phase angle jump of a system are influenced by the location of the fault. The results also show that the system with dynamic load has different outcomes compared to the system without the dynamic load during unbalanced and balanced fault. In conclusion, the objective of this paper to analyze the unbalanced fault location under dynamic load is achieved. However, further studies can be proposed to analyze the line-to-line and double line to ground fault considering the dynamic load. That's all from me. Thank you.